Next on my list, I want to come up with an example where I'm computing arc length. How about this? Now, you probably recognize this as a limousin, that's French for snail, with an inner loop. Let's see if you and I can't compute the length of the inner loop portion of the graph. Now, if you're having a hard time graphing this in your head, you could cheat and go back to what I did with my first example, the cardioid. You could refuse to sketch this graph in the XY coordinate plane and first graph it in the R theta plane. That is to say, sketch this rectangular graph first. It's just an inverted cosine wave, whose max R value, locally speaking, is 5, min R value, locally speaking, is -5. Shifting up 2 units gives you a max R value of 7, min R value of -3, and a median R value of 2. It's an inverted cosine wave, so it starts and ends at its local min R value. Whoops. And so begin and end at the local min R value. Halfway through, max out. 1/4 and 3/4 way through, attain our median R value. Looks to me like it's this. At least that's one full cycle of it. Now, I have to admit, something interesting is happening here. Technically speaking, I cross the theta axis twice. That might be an interesting value for theta, so let's find these values of theta. The first one, I'll call it theta sub 1. It's the angle in the first quadrant whose cosine is 2/5. Wouldn't that be this? Here, in the XY coordinate plane, that would be an angle in the fourth quadrant whose cosine is 2/5. So wouldn't the second one theta sub 2? Gosh, can you read that? Okay, it's not dark enough. Now, if you can read this, I'm not changing it. But because I can't see that on my screen with the blue pen very easily, I said theta sub 1 is, I forgot what I said. Inverse cosine 2/5. Oh, that's what I said. But likewise, in the XY coordinate plane, it's going to be the case that I attain another such value for theta in the fourth quadrant, whose cosine is 2/5. Wouldn't that be one full rotation, backed up by that reference angle? Now, that being the case, in the XY coordinate plane, let me go ahead and plot those two special angles. Here's theta equals theta sub 1. Here's theta equals theta sub 2. And let's quickly sketch out the polar graph and compute the length of the arc along the inner loop of this limousin. So as I rotate from 0 to that first angle theta sub 1, my R values increase from -3 up to 0. So look at strict polar axis. I'm going to start at -3, and I'm going to walk by rotating from here to here, increasing theta to be equal to 0 at that particular value for theta. As I rotate from theta sub 1 to pi halves, my R values continue to increase from 0 to +2. As I make a full quarter rotation from pi halves to pi, my R values continue to increase from 2 to 7. And everybody, I know I'm being sloppy again. I'm not unitizing my axis, but at least I got the rough idea. That's all I really care about. Now, as I continue to rotate one full half rotation, I'm just undoing everything I just did. So I've got that symmetry. And I do think I'm going to end up looking like this. If I get my positions correct. Okay, I did it. So it looks to me like the inner loop's generated, rotating from 0 to theta sub 1, and then also rotating from theta sub 2 up to 2 pi. And I don't want to do it, so I'm going to cheat. I'm going to go ahead and just compute the arc length that I generate when I rotate theta from 0 to theta sub 1 and double the result. That'll give me the full length of the inner loop. So at least in just setting up an integral, the arc length will be 2 times the integral from 0 to theta sub 1. And where's my eraser? In the integrand's position, I have this. Now, drd theta is merely this. So its square is going to be this. Add that to r squared. Sorry for my sloppiness. I'm running out of room again as usual. And I don't know, looks pretty darn clunky. I know I can combine these into a 1. Add it to the 4 gives me 29 minus, I'll just write it. Which looks pretty awkward, so I'm just going to set it up. I don't know, maybe I should tack on just one more example where I actually finish up computing the actual arc length, and I will do such. I'll go back to that cardioid.